Hello physics students, welcome to another video, yet another one. This is number 8 on inclined planes. Now we've mentioned inclined planes before when we were doing the skier, and I think there's a car, and so this diagram is pretty much saying everything that we said about that before, with the only addition is that if the acceleration is due to gravity, you can use this equation here, where the acceleration parallel to the plane is given by g sine theta, where theta is that angle. And we can show you how to work that out, or you can just write it down. And so that means that as this angle decreases to 0, the acceleration decreases, and as this angle increases to 90 degrees, the acceleration approaches 9.81 meters per second, because obviously if you had an inclined plane at 90 degrees, it's the same as dropping something. Just a little slightly different terminology from what we had before, because it's from a different textbook, but exactly the same arrangement, where you have your weight force, you have your component which is parallel to the surface of the weight force, and you have your component which is perpendicular to the plane, and then you have the reaction force or the normal force such. Okay, so let's do an example, and this is a slightly different example from the ones before, because if we look at it, what it says is there's a 15 kilogram wedding cake. It's allowed to slide freely down a smooth 30-degree incline. Why you would slide a wedding cake down an incline, I don't know. And you're asked, what is the resultant force down the incline, and what is the acceleration? So in this case, the object is accelerating. So there is an unbalanced force, and it's unbalanced because it's a smooth surface. And so effectively they're saying that the resistance is 0. And we can see now that the force down the incline, they did their little maths here, and they did force parallel equals F weight times sine theta, and F weight is mass times gravity. They used 10, we would use 9.8. And so they worked it out, and basically they were working out this component here, which corresponds to this arrow here, and they got the force as 75 newtons. Then they wanted to know what the acceleration of the object is. Now they used their equation that we had before, A equals g sine theta, and they got 5 meters per second. But what you could have also done was, let's see if we can write it up, they could have said that F equals ma. So if this force is down the plane, 75 equals 15a, therefore a equals 5 meters per second to the minus 2. And so the acceleration is equal to the component of the force, or is proportional to the force given the mass of the object. And you can see that there's no resistance here. Now, if you could get the situation where, for example, if they said the acceleration was 4 meters per second, they would then perhaps ask, well, what is the resistance? And the resistance in that case would be 15 newtons, I think, because you'd have a component going against the actual force that's parallel to the plane. I hope you understand that. It gets a bit twisted, but hopefully that's clear. Again, as always, if you have any questions, write yourself a little note in your video notes and come and see me in class, and we'll have a chat about it, and I'll draw some things on the whiteboard. Alright, next. For some reason I put that there. Yeah. So this is just the resolution of the vectors. Now, we're going to go through a whole lot of examples of inclined planes, because you go, well, inclined planes are pretty boring. But they're not. They're everywhere, and some of them are fantastically interesting. This is an example of an inclined plane. This is a huge inclined plane ramp that sends basically a swimming pool full of water with boats on it up, and so it's a lock. And so you have a barge, a canal system, and you have two different levels of canals, and so instead of winding around kilometres at a very low gradient, you have a lock which allows the boats to go up to a higher or lower level. And sometimes these are water-based, but this one seems to be going up quite a gradient, and therefore they have to have this massive system. Imagine how much energy is being used to haul that up. Well, there's actually a counterweight that uses it, so it's quite efficient once it's actually made. This is another example of a similar lock with a big ramp, and that's the tower that has the counterweight in it. And this is what it looks like from that top of that tower, so it's massive inclined plane. And that's the swimming pool where the boat sits in, or the barges. Ben Lomond Road is an example. If you've been up to Ben Lomond, you go up here, and that's an example of an inclined plane. And there's another example of an inclined plane, twisty roads. And there's a classic example as well. And some people actually use inclined planes in art. This is a installation or a sculpture called Inclined Plane, and you get to walk up the stairs and go through the inclined plane and out the other side. That's art. Rightio, on that note, let's stop this video, and you can pick up projectile motion in the next video. See ya.